Okay, welcome to this video on the DCG 2022 question B3 by Val, and there's our marking scheme there shown. So welcome to this video on the 2022 exam. So our 22 exam is question B3. So we're just going, here's the solution of it. There is the question. So I'm going to outline how we done it, how to get the traces, okay, of the oblique plane that contains the touch screen, right? Then, okay, how to draw offset the black frame in the elevation and plan, because the distance they're offset are not true distances in elevation and plan. And then how to find the back touch screen here. So this here, how to find that, and how to find the true angle. So not going away. Right, here's how we're gonna, or here's a model in SolidWorks. So here it is in 3D. So I have my outline plan and elevation. And now to find, okay, these in 3D, I'm going to draw, I extended the base of it there, to get my HD, and I picked what went on the surface, okay, and I went parallel to the HD in 3D, okay, until I hit the XY line in plan, and I'm going to go upwards and go across, because this line here you see, that one there, okay, is horizontal in elevation. That's going to get me a point on my VT. And you can see my traces going through. Then, that's the plane. Okay, the bezel on the screen. Okay, so how did I get that there? So I'm going to do an auxiliary elevation, looking along the HD, and I can offset. Right, if I went in 8 millimeters, this is 16 in the passion, if I went in 8, okay, I think this is going to be scale east 1, or maybe it's scale east 2. So there I'm going to go in 8 millimeters in the auxiliary elevation, and then I can project that back to my plan view. And you'll see where that's going to project backwards as per the sheet. Project backwards, and this distance here of 8 millimeters can be put along the base, because it's the true plan. Now, the true angle between the base, okay, and the stand, 35 degrees, can be seen when both planes project as edge views. So the stand here is going to be an edge view, horizontal plane is going to be an edge view. And then the true angle between them can be seen when both planes are again edge views, the dihedral angles. The front stand and the back stand is an edge view there. So we'll go through the drawing now, how we've done that. Right, so I'm going to start. There's the question there. I have to draw the kickstand, or the touch screen. Here's the dimensions. Scale 1 is to 2. It's got by an oblique plane. So I'll have to draw the outline plan and elevation. So I'm going to draw my XY line. The angle will be 35 degrees. I'll divide all measurements by 2. So I'm going to draw this in. Down 70. So I'm going to draw in that base there parallel to it, to the 35 degree line I drew. I'll mark 120 down along that line. I'll probably move the camera now shortly. Now, go perpendicular to that. So I can mark then 60 along it, or 30 and 30. So one will be the center line. And then I've got my hinge line that'll be for the kickstand. So I can draw in the sides of the outline of the touch screen. I'll project upwards from my elevation. My key principle in this will be parallel lines are parallel in every orthographic view. And the height there I think is 62. If I find my sheet, so I'm just drawing in my elevation there. Now I can draw in the hinge line for the kickstand in elevation. And now I'm going to get the traces in my plane. So the base of the kickstanding plan is along the HT because it's on the XY line there. Yeah, as you see in the SOLIDWORKS model. And it contains a point on the surface. And parallel lines are parallel in every orthographic view. So you can see as I just click there, I'm going to draw a line in plan. It's parallel to the HT and go up towards my elevation. So what you'll see me first do is extend on the base there, that's on the HT, because it's on the XY line elevation, so it's on the horizontal plane. Then I'm going to draw a line parallel to the HT from this top left point in plan. And where it hits the XY line, I'm going to go straight up, because that's where it hits the VT. And I'm going to go across an elevation and join that back to T, because that's parallel to the HT. Now, I have to draw in the bezel in plan and elevation. So I'm going to project an auxiliary looking parallel to the HT. I don't necessarily have to do this, it's one way. And I'm going to draw in the X1, Y1 line, and I'm going to take my height from elevation. So that's the X1, Y1 line. I'll eventually move the camera here in a moment. So I'm going to take that height from elevation and put it up there. Okay, and the plane's going to project as an edge view. Now, you can see me have moved it there. Okay, so I'm going to mark the true distances 8 millimeters along this, because the sides of the plane are projecting as true lengths. So it's 16 divided by 2. And then I mark 8 along the base there, left and right, because that line is on the XY line elevation, so it's the true length in plan. So I can project these backwards. And project these parallel. Remember, parallel lines are parallel in every orthographic view. I can bring them up to elevation, so they touch the side, and they touch the base. And then I can draw parallel to the side of it. They're parallel in plan, so they're parallel in elevation. So I can bring that across them. Then I can heavy them in. And I can heavy the plan view in. There you can obviously see I forgot to finish off a little bit there. Hopefully I'll do it later. Now the kickstand makes an angle at 35 degrees with the horizontal plane. So I drew that in, and now I've seen where my hinge line would be in my elevation, auxiliary elevation, and I drew a 35 degree line from there. And there's the base there. Okay, where it hits the X1, Y1 line. And I can project that back down to plan. So that's the bit where the kickstand hits the HP, there where it hits the X1, Y1 line. So that's it, what I'm on about now. So I'm projecting it back down. So I can put in my plan of my kickstand, then I can bring it up from my elevation, be some hidden detail. There we go, and then the true angle will be seen in our auxiliary elevation because both planes appear as an edge view. Alright, and the line of intersection appears as a point. It's like a dihedral angle, and that's the video done. And then I forgot to heavy in that little bottom right corner, the touch screen. Anyway.